So for the last few days, we've been looking at quadratic equations and specifically how certain changes are reflected in the resulting parabolas, the resulting graphs. So for example, y equals x squared minus 3. It's the same parabola, just everything's bumped down 3 units, right? The y values are just 3 less, right? So it's a standard parabola, just lowered 3 units. Now if we start changing things inside of whatever gets squared, it would take whatever x value, your standard x squared parabola, but whatever x is, it would be 3 less than that. So you get some horizontal movement there. X minus 3 moves it forward, moves it to the right, or x plus something moves it back into the negative space. Okay? And then if you add a negative sign, y equals negative x squared, it flips the parabola. And then if you add what, like a scale factor, it ends up stretching it, right? A stretch factor. So then what we did was we were looking at these like square type of diagrams, right? And we're saying, okay, if we're looking at x plus 3 squared, we can say, use this space to be, it's a square that's x wide, and then we've got these bars that are 1 by x, right? So if we want to represent x plus 3 squared, we can say this square is x plus 3 by x plus 3. And then we can kind of continue with our diagramming and then count these little segments and come up with something like this, right? So this is a square, x by x, so its area is x squared. Now these bars are 1 by x, so each of them has an area of x, and we've got 6 of those bars, so 6x. And then we've got this little area here where it's like a 3 by 3, and these are all 1 by 1, right? So it's 9. So this is a nice like diagram for showing how x plus 3 times x plus 3, or x plus 3 squared, equals x squared plus 6x plus 9. So what we're going to do today is we're going to go the other way, okay? And we're going to look at an equation that's in standard form like this and try and get it into vertex form, what they call vertex form, right? So in this form, we can quickly know, like these kinds of equations, we can quickly tell what the parabola is going to look like without having to think too hard or do any calculations, really, right? So this is a really convenient form to have it in. So let's look at number 1 here. So y equals x squared plus 16x plus 71. Now, what we're going to try and do is we're going to make a square diagram, draw a square diagram for each of these problems, draw a square diagram, and see if we can't, if that doesn't help us, okay? So let's start here, just number 1, and I'll draw a little graph here. Make sure to make it square. Oops. Okay, and we'll just say this is x, and in here will be our segment for having like the bars, and then these will be the ones. Okay, so 16. Here's our x squared, right? And then these. Now if we have 16 bars and we've got 2 quadrant, it's going to be 8 bars in each, right? So 1, 2, 3, 4, 5, 6, 7. 7 cuts gives us 8 bars. And we'll do the same again. 1, 2, 3, 4, 5, 6, oops, 7, okay. And so that means that this is 8 wide, this is 8 wide, and this is x plus 8, x plus 8. And really, the important part here is that we're looking at this section here, okay? We're looking at x squared plus 16x. And now, so the area of this is, well, we've got 8, it's an 8 by 8, so this area is 64, right? So this square is, first of all, it's an x plus 8 times x plus 8, or x plus 8 squared, equals x squared plus 8, 16, 16x plus this part is 64. Okay, so this is useful, right? This is useful information. So now what we can do is we can go back here and we can sub in this part, and just hang with me while I do this. X squared plus 16x plus 64. This is kind of what we're looking for, right? So if we add 64, we can just subtract 64 over here, and then these cancel out. And this part is equal to our original equation, right? X squared plus 16x plus 71 plus 64 over here minus 64 over here. These cancel out, and it's the same thing. Only now we can substitute this with x plus 8 squared and simplify this. 71 minus 64 is 7. Wait. Yeah, 7. Okay? Now, here we go. Vertex form. Okay? This is great. We know y equals x plus 8 quantity squared plus 7. We know it's whatever this is shifted up 7, right? And it's going to have a horizontal shift, x plus 8. That means it's going to go back about 8. So up 7 and back 8. In other words, looking at this, right? This is the vertex form. Your vertex is h comma k. It's minus 8. That's your vertex. Okay? Pretty cool. All right. So that's kind of what I want you to do. This, drawing this diagram and illustrating this equality of this is a squared amount that you can kind of find when you're looking at this segment of the equation. Okay? This is a very important step. Include that. This is a very important step because now you're substituting. Okay? Include these two steps and draw your diagram. All right? Now, it gets complicated quickly here. Okay, so let's look at number 2. Now we've got a negative. All right? So what we're going to do, let's focus on this. All right? And this time what we'll do is we're going to say this whole thing is equal to x. We're just trying to visualize, you know? We're going to say this whole thing is x squared, and we're going to try and see what it looks like when we take away 2x. Okay? So here's 1x. This is x squared minus x. All right? And then I'm going to draw that. And we're almost at 2x, right? This would be x. This would have an area of x if this is 1, right? That's a width of 1. But this has already been taken out. Okay, so to represent that, we know that this is 1, right? Because it's the intersection of these two. 1, 1, so this is 1. So if we wanted to take away another bar's worth or another worth of x, we could just put that 1 over here. And we'll say that this is 1 by 1. So now we have x squared, and we're subtracting x, 1 times x, and 1 times this right here would be x minus 1, right? X minus 1. And this little guy here, which is meant to be this long bar's friend, his worth of that. So this is our remaining piece here. So this side is x minus 1, right? X minus 1. And this side here is x minus 1. So this is a square of x minus 1 squared, but now we got to minus this little guy here. So x minus 1 squared minus 1 equals x times x minus 2x equals x squared minus 2x. Okay? So we're trying to get something like this. So all we're going to do is we're going to move the 1 over, and that gives us x minus 1 squared equals x squared minus 2x, negative 1 over here, add 1 to both sides means positive 1. Okay? Now we've got some useful information. We could do something like we did before. Okay? Y equals x squared minus 2x plus 1 minus 5. And then we're going to subtract the 1 again, right? Plus 1, now minus 1. Okay? So, important step. Next step is we're going to substitute here x minus 1 squared and combine these, minus 6. And there we go, vertex form. Everything's shifted down 6 and to the right 1. So our vertex is 1, comma, negative 6. Right? Okay. Yeah. So there's some interesting stuff in here. Ooh, this, yeah, now what? No problem. Just factor out a 2. Everything's okay. Plus, what's that? 18x. 170 divided by 2, 85. Okay, yeah, do your thing. Yeah, might have to multiply that out, add a couple steps there. Okay, so this is pretty close to vertex form, so don't need to worry about a diagram there. No diagram there. Okay, so now these are in vertex form. Go ahead and just, use what you know. Think about it. Okay, everything is shifted down 4. And then we've got some horizontal movement. X minus 2, so it's moving to the right 2. Okay? Negative. Ooh, stretch factor less than 1 and negative. All right. Interesting stuff. Cool. All right, a lot of good stuff here. Try it out. Have fun. See you on Tuesday.